Hey folks, welcome back to Precalculus. Today we're in chapter 5, section 4, talking about the graphs of tangent and cotangent. Okay, so we'll talk about the physical representation of tangent and what that represents on the unit circle in class. But for today, what we're going to do is use our tangent values all the way around the unit circle to help us derive the graph of tangent, and understanding that as we go around the unit circle, these tangent values are simply repeating. Just like sine and cosine, it's going to continue to repeat forever. Okay, so we notice that the tangent of 0 is 0. Okay, so let's go ahead and graph it. Now we also notice that the tangent of pi halves is undefined. So we're going to have a vertical asymptote there. And if we also take a notice, the tangent of negative pi halves is also undefined. So we're going to go ahead and put some asymptotes there. So I'm just going to go ahead and call this pi halves, I guess. We'll go 3 spaces as pi halves, and this will be negative pi halves. And let's throw some asymptotes down. Okay, so there's our graph. Or I should say our period, because we can tell that the asymptote is going to repeat right there. Now, it's important to notice, like, how long does it take the asymptote to repeat? Well, pi halves plus pi halves, a half of a pi plus a half a pi is going to be a whole pi. So it's easy to see right now that our period is going to be pi. Meaning that when we go to find period of different equations involving tangent, we are going to be using the equation pi over b. Okay, let's get back to graphing. So here's our 0, here's our asymptote. Halfway between 0 and pi halves is pi fourths, which is 1. This is a very easy value to graph, so let's go ahead and just graph that one. So pi fourths will be halfway between, it's about right there. So we'll call this one, this -1. So there's another point on my tangent graph. And if we look, negative pi fourths has a tangent value of -1. And we can talk a little bit more in class, if you'd like, about the physical representation of tangent and why it shoots off to negative infinity to the left and positive infinity to the right, bounded by our vertical asymptotes. Okay, and if we keep on going, we can see if we go to tangent of 3 pi fourths, notice we have -1. Tangent of pi is 0. And the pattern just continues, folks. Just continues. And we could draw more than one period of our tangent graph. There you go. So you can see right away that our range, bottom to top, is going to be negative infinity to infinity. Our domain is essentially all reals except for pi halves, 3 pi halves, 5 pi halves, and so on. So we can start by saying negative pi halves to pi halves. I mean, it goes in both directions. Union with pi halves to 3 pi halves, and then so on and so forth. Okay, all the asymptotes are at they're pi apart at all the pi halves. And obviously there's infinitely many of those as well. Okay, and we can see here that if we reflect over the x-axis and reflect over the y-axis, we get the same point. So we know we're symmetric to the origin. So everything else with graphing tangent, we're going to do some examples here in a moment. Everything else with graphing tangent is exactly the same as graphing sine and cosine, except we use pi over b to find our period, versus 2 pi over b with sine and cosine. Okay, so now let's dive into graphing cotangent. Okay, so you want to flip to this page next. And to graph cotangent, we're actually going to start by graphing tangent. So all I'm going to do is take the exact tan graph and just draw it in light pencil. If I were you, I'd draw it in light pencil. I'm going to do mine in marker, but I would draw it in light pencil. You just need to know where the points are on your tangent graph. You don't want to see them too much. And there, I think you can see that. Draw a few more. Let's go to the left, one period. And you should have, 3 periods of a tangent graph will help us draw our cotangent graph pretty efficiently. Okay, now it's time to reciprocate these tangent graphs and turn them into cotangent. All right, so let's first talk about the x-intercepts, the zeros. Okay, the zeros. If you reciprocate a 0, meaning go 1 over 0, you can never divide by 0. Anything over 0 is always undefined. So wherever tangent has an x-intercept, cotangent is going to have a vertical asymptote. So wherever tangents x-intercepts are, cotangent is displaying a vertical asymptote. Now let's talk a little bit about tangent's asymptotes. Well, tangent has an asymptote because it's 1 over 0. Okay, all these different places. But if you reciprocate that, you get 0 over 1. And 0 over anything is always 0. So wherever tangent has an asymptote, cotangent is going to have an x-intercept. Pretty cool how they just kind of trade x-intercepts and asymptotes. It is going to affect the shape, though, a little bit. So now let's take a look at these tangent graphs, and let's reciprocate all these values of 1 that I'm pointing to right now. The reciprocal of 1 is 1. So this point's going to stay in the same place. Same with this one. Same with this one. The reciprocal of negative 1, we got a few of those down here, is still negative 1. So it's going to stay there. And you can see that it kind of flips the direction as well. And in red there is your cotangent graph. Okay, your cotangent graph. I will draw special attention. People think it's simply a matter of just changing the direction of the tangent graph. It's not. No, remember that wherever tangent has x-intercepts, cotangent has asymptotes, and wherever tangent has asymptotes, cotangent has x-intercepts. So that means that the vertical asymptote for cotangent will be on the y-axis before you start sliding it around and everything. So let's talk a little bit about the characteristics of it. We know that x-intercepts on the tangent graph, meaning vertical asymptotes on the cotangent graph, are pi apart. So the period must be pi. Thus, we are going to be using the equation pi over b. And notice we still have the same range, negative infinity to infinity, all the way down to all the way up. And the domain is still pi apart. So on and so forth. And our vertical asymptotes are still pi apart, etc. And if we reflect over the x and over the y, we get the same point. So we are symmetric to the origin. Okay, let's do some examples together as a class. All right, the examples are going to help us the most. So we got a tangent one first. So first things first, let's figure out our period. Period is going to be pi divided by pi fourths, which is the same as pi times 4 over pi. So our period here is 4. I know that my tangent graph always has an x-intercept at the origin. Well, then that's going to repeat 4 units away right there. And then every 4 units, my x-intercept is going to repeat. Same thing with our vertical asymptotes. We know our vertical asymptotes are halfway between our x-intercepts on all of our periods of tangent graph. So draw our vertical asymptotes. One more. Starting to look like a tangent graph. Now, with a tangent graph, we have a vertical stretch right here. Now, a tangent graph is not a wave. So it does not have an amplitude. It does not oscillate like the sine and cosine graph. It does not have an amplitude, but the vertical stretch affects it in the same way. This 3 is going to affect it in the same way. So where we had a point at 1 is now in our new tangent graph going to be at 3. And where we had a point at -1 is now going to be at -3. So rather than going up 1 and down 1 halfway between the x-intercept and the asymptote, we're going to be going up 3 and down 3. And here's the period of our tangent graph. Draw some more here, make it look good. Just like that. And you're done. Okay, so let's go ahead and do a cotangent one. This one looks a little uglier than you think. We just need to remember that this t over 2, x over 2, whatever, is actually, we can write this as 2 cotangent of 1/2 t, not an x, t. Okay, so our b value is 1/2. It's that simple. So let's go for it. Period pi over 1/2, which is pi times 2 over 1, which is 2 pi. Awesome. Now here's why this is cool, because we know that our cotangent graph starts with a vertical asymptote on the y-axis. Awesome. And we know every 2 pi, that's going to repeat. The definition of a period, how long it takes for something to repeat. So let's go 6 boxes and make another vertical asymptote. I'm just choosing 6 boxes to represent 2 pi. And we can go 6 boxes the other way. Maybe we can get another one in here. We can. Let's do it. Beautiful. Okay. Now, yeah, this would obviously be -2 pi. Okay. So, on our cotangent graph, if we remember, halfway between our asymptotes, here's an asymptote, here's an asymptote, here's an asymptote, here's an asymptote. Halfway between, an x-intercept. So let's go ahead and draw our x-intercepts. Easy peasy. Sorry, going off the screen there a little bit. Now, notice halfway between our x-intercept and our asymptotes is where we are going to have our quote-unquote amplitudes. They're not amplitudes, but we can treat them as such because they're affected by that a value out front. So our a value here is 2. So we know we'll call this 2 and this -2. We know that halfway between that is going to be a 2, -2. 2, 2, -2, 2, -2, and now we have our cotangent graph. Three whole periods, and I'm going to get a partial period. This thing kind of continues, but stop labeling. Awesome, and there you go. That's your cotangent graph. I hope you guys enjoyed. If you have any questions, please let me know. I look forward to helping you in class.